Hey everybody, Aaron here. So it's time for an actual project as opposed to just like welding practice. It's a big pile of over here, just out of the shop. As you can see by this collection of bits on my list to make is an exhaust. So I have these laser cut flanges to suit the Ford FE. I have a couple of different styles. These will actually need chopping up into individual flanges. But I want to make like a purge fixture so that I can purge the inside of the pipe with argon. And it's not going to be round at both ends for the whole time. Right? At some point, it's going to be attaching to this. So it'll be squished. This one I made earlier. Oh, face. So here's one I made earlier. Sort of that sort of shape. This still has to be like worked out to meet all of the corners. But once it's been heated cherry red and worked out to meet the corners, I gotta purge it somehow. And I spotted a picture of a similar fixture that Ollie at Aluminium used on Instagram. I thought I'd have a bash of making my own. So what we're gonna do is, first of all, cut down this piece of 4" by 1" by 7-8 inches to a size that is a little bit easier to work with. I kind of thought the flanges would fit this way, but framing, there we go. Kind of thought the flanges would fit this way, but they don't. So I'm gonna have to cant it over. That gets me like the smallest amount of material. I'm not like too precious about how much material I use here. So probably something like that. We'll cut it off down there, so we've got like this. You need my new transfer punches to transfer these holes through, drill and tap them for, they're Imperial, but probably M10, just because I have more metric stuff lying around. Then these can be bolted down to this aluminium. And what I'll have to do is basically cross drill in from this end and then drill down to meet that drilling, right? So that I'll come out in the middle. Let me grab a pen from behind you. So let's say that this is a terrible pen, but let's say that, yeah, we're going to lay this out to be about that long. Right? It's going to be, about that long. And the middle, roughly, it's going to be somewhere around there. So we're going to have to drill down from the middle of this top face here, down here, right? With like a, 6mm drill, something like that, to get down to somewhere here. It doesn't matter if we're a bit past the middle. And then we're going to have to drill down from the top so that we have a gas passage. And then I can probably get some fittings. I've got some here. Some of these guys. Right, the little push fit guys. Maybe one of those. So having drilled, M6, we're going to have to drill out for the tap size for that, and then tap it, whatever that is. Or a hose barb, or something. So that I can connect an argon line to there. And that will be my purge fixture. So the first thing we're going to do is mark this up and cut it off. super accurate, doesn't matter, but we'll use the bandsaw and then get drilling. So it will actually probably be tomorrow, because it's getting towards lunchtime. And if we pan up a little, you can see what I did earlier, which was basically run enough practice stainless steel welds, of which some are like, you know, acceptable, passable, a little rainbowy. That I ran out of argon. And I mean, then I was forced to tidy. Wasn't very successful over here, as you can see, but hey. Alright, we're back. It's another day, wearing a different shirt. This is a Savage Industries measure once, cut twice shirt, which is appropriate, because I didn't show you cutting this at all. Turns out the bandsaw takes a really long time to cut through 1-inch plate when you don't change the blade to a coarser blade or speed it up. Anyway, what we now want to do is mark out where the holes are going to go to meet the flange. So to do that, I bought a set of these. These are transfer punches. You see they've got a punch shape on one end, and they are nominally sized to fit holes. Now, unfortunately, the holes all have a little bit of slag in, so what is probably the right size one won't go through 12, but 11.5 does, even if it has a bit of wiggle room. This is essentially non-critical, right? I'm probably only going to tap this out for like M10. So it's just a question of not moving the thing when I do this. Tell you what. In an effort to make sure that doesn't happen, I'm getting tape. When I have a clamp that I made up. So, yeah, that seems about right. I don't have you on the table for a better view because, well, because this. You'd be jumping up and down. Now, for no good reason, I kind of want my gas to come out roughly in the middle, so I'm also just going to put a little mark in the middle, roughly in the middle. We can figure out how to get there in a minute. So what we've got is, oh, you can't see those. There's a dimple there, dimple there, dimple there. So I just want to draw a line up and then transfer it around the face so I know where to drill. It's not my engineer square because that's up the other end, but this is aluminium, so describe it with anything. Now it's 1-inch plate, so we want to be in the middle, which is there. Well, you can't see this because my hands are in the way. And we'll just give it another, yes, I know, I should go and get my center punch. These are not critical dimensions. So there, we've got a scribed line and a scribed line that translates to the middle of this plate. Dimple, a dimple, so we've got to go down this face, half the depth, and then down this face, basically half the depth. Let's just measure how far that is, roughly. A gasometer that really needs a new battery. So, $46 down in that face, and then obviously 13 down that face. So, 46 down that face. And 13 down that face. So 46mm down, 13 down. To the drill press, which is over there. And we're at the drill press. Ready to watch me struggle? Always struggle with the drill press for some reason. I don't know why. Anyway. I'm going to go with I was going to go M6, well 6mm, but my 6mm drill bit looks incredibly blunt, so I'm going to go with a 5.5 instead. I can never remember which way to turn the chuck. One way, well, there we go. So, it's a cheap and nasty drill press. It's like the equivalent of the Hazard Fraught, or otherwise known as Power Base XL. It's basically just a Chinese, clone of a Chinese clone. So, we got about 13mm down. So, trying not to smash the thing into the drill bit. There we go. So, I need to go about down 3, 4, so about 17mm on there's a scale. You can't see that. See, it's a scale on this pointery thing here. It's highly inaccurate, but close enough for government work, as they say. So, I'll go down to about 15mm. See if this thing whips around and smacks me in the ribs. Ooh, that's did you see that? Doesn't come across that video. It's like the most epic amount of run out, because apparently I did not get the drill bit in the middle of the chuck. I got it like offset. That takes skill. Skill, I tell you. That's better. Down we go. About 10mm. All right, I'm about 16mm in. Give myself a bit of headroom. Again, not critical, I just want two holes that, intersect, right? So if I'm up here, whatever, the gas is still going to get up there. If I punch all the way through, I could just weld up the back, to be fair. So, I'm One hole done. I would love a drill press with height adjustment. Who am I kidding? I'd love a Bridgeport mill. If anybody out there has one, you know, going spare that you don't need, wants rid of it for a good price, let me know. Now, you can't see what I'm doing because everything's moved down a bit. But close the vise up. So, hole, right? Doesn't go all the way through. Can't see my hand. Can't see my hand. Want one up there now. That matches. Hopefully. That's not going to work. This is where we run into the whole... My vise is, you know, height problems. Because the table only goes so far down. And... yeah. But it doesn't reach. So let's get some really hokey setup going on. Wood. How much wood would a woodchuck chuck if a woodchuck could chuck wood? Vertical-ish, I hope. Let's see. I'm out of depth after like 6 millimeters. So wank. More wood. Oh, look at that, just sneaks in there. Okay. Down a bit further. Come on. See all these razor sharp, you know, burrs? Not a good idea to get them off with your hand. Anywho, about 20 mil in. Let's keep going. nearly there, I think. Oh yeah. When I get all the way down, if I'm on target, I should just intersect. Stupid aluminium. It's welding itself to the end of high-speed steel tools. Okay, give it another bit. Do you know what? It actually intersects. So, let's just see if we can clear some chips. Whack ourselves on the finger. And there's no way you'll be able to see that, but maybe I can demonstrate. See in the hole? You just see the drill bit? Yeah. I don't know. Focus. That's like blurromatic. There you go. Just see the drill bit. Success! Who'd have thunk it? With some incredibly janky setup, you can actually make that hole and that hole intersect. Despite the fact that my setup in the end was some decking board and a lump of 6x2 with a shitty engineer's vise, well, drill press vise, sitting on top of it. Brilliant. And that, folks, is why I have an endless supply of chunks of random wood. So, now to drill and tap the 2 holes that will hold the flange on. Bear with me a second. I need to tidy. Just leave that there. Bring the vise back. And open the vise back up again. And figure out how to However, I am going to have to probably drill this in stages up to, what are we, 8.5, so we'll start with a 5.5, then an 8.5, and then we'll M10 tap it. If I don't go all the way through, I do have bottoming taps, so for those sizes. But, yeah. Okay. Contact. Got a bit excited. And all I did was jam chips up in the flute. Okay. One down. One to go. I'm going to get beaten around the hand by, there we go, big ol' spinny hot chips. Okay. Now we go up to 8.5. And I can't get the drill out because the work's in the way. I will almost certainly have to move the table down. You know, I don't know if it comes across on camera, but when you're actually drilling, it's like an enormous amount of flex in everything that does not inspire confidence. But I should probably drop it down a tad. Okay. Oh, down a tad more. And bigger hole. Ow. Ow, 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 ow. These things, like little whips. Okay, one hole. Let's go for the other hole. Can't really, yeah, should reposition the working device really. Because, you know, that's much safer than the thing teeter-tottering. Okay. Man, there's a lot of play in that. Ow. I tell you what, these, basically brand new set of tapping drills. Really sharp. Love that. That neutral feeling. Alright then. We've got all of our features machined in. Need to tap these holes. So, I'll take you back to the workbench. And we're back. Magically at the workbench. So, off camera, I had to do a little trip to the other workshop My tools are sort of split right now between the top garage, where there's now nothing left, and the bottom garage, and I need to go and pick these up. These are my, for the size taps I use, my favourite way of running taps, actually, usually this guy, the smaller. This is a Ritter, made in Germany, for 4.6 to 8. I think it'll work with the 10. Yeah. So I like them, because generally speaking, they're like a little, yeah, there we go, like they're a little collet, essentially, like a drill chuck almost. And once you've tightened them down, usually they don't fall out the end like it does with the tap handles. And they are ratcheting both ways, all fixed in the middle. So I don't have a sprung tap follower. These are big enough that they're probably just going to sort themselves out anyway. And I've got all 3 taps, first, second and third. So, and this is aluminium. So really, how hard could it be to tap? I wonder if I can just, oh yeah. Can't rotate now, so I put a dog in. So get it started. They're great because you can wind them in forwards, so you feel it start to load up with chips. Flip the ratchet, break the chips, carry on. If I'd been really smart, I'd have put this in over one of the holes in the fixture table. But I'm not, so I didn't. But I'm gonna now. Probably about there. Yeah. Put that there. There we go. Yeah. Now it's going through a hole in the fixture table. Bet you don't have any M10 bolts handy down here either. Might do. Half my bolt supply is also at the other end. This is tedious, isn't it? Speed this bit up, because you're just going to see me do the same thing 3 times in a row. And hopefully not break a tap. When it goes really loose, you know you're all the way through with the biggest, deepest section of the tap form. And then you just have to spin it back out. That's one. You probably won't be able to see that. Maybe I'll put a close up in. But on the first tap, the tap form's only about 50% of the thread depth. Second is like 75% and so on. So that rather than trying to, you know, mush the whole thread in there in one go, you're actually only forming a part of it at any one time. The first tap is always the hardest, because the first cut is the deepest. God, I hope I remember to keep that in the edit. Once more into the breech. There we have it. One. Through tapped hole. Yeah, you can't really see the threads. I shall prove it in a moment. But first, do the same thing all over again. Last one. And there it goes. If I kept running it, it would just fall out the bottom. The nice thing is, if I do strip these threads, I have the option of just going up a size in this block and helicoiling it, because I have, I think, an M10 thread repair kit. And helicoiling aluminium isn't always a bad idea anyway. The aluminium's very soft and doesn't always like being repeatedly bolted into and unbolted. Good if I had the airline hooked up with it. So, see if I got an M10 bolt. Guess what? M10 bolts. So the way this thing will work is, I still have to drill and tap that to actually accept some kind of air fitting. And that will bolt onto there. One bolt. Two bolt. And assuming everything is fairly flat, which I will check, there's your fixture. Done. Almost. Almost done. And then you'll just be able to jam your... This doesn't quite fit. In. Hold on. There's a knack. There we go. Yeah, I'll be able to jam that in. And grab the old torch and around it. Obviously it's going to be tricky into there, but probably doable. Push comes to shove. Just take one bolt out. Speaking of, better make sure I use bolts that are actually short enough that they come back out when there's an exhaust in the way. So probably 2 of my runners are going to do this. So on the engine, it's like that way up, right? It's vertical. So 2 of my runners will come down. 2 of my runners will need to come off and go sideways. So 2 are going to be much easier to weld. 2 are going to be a bit of a sod. Let's check. So is a bolt this long? Too long? No. In fact, about the right length. Complete engagement. I'll find some regular bolt head size ones. Use those instead. But yeah. That's that. Argon goes in. Argon comes out. Argon goes in. Argon comes out. It's a blanking plug. Tin foil, something. Job done. That is it. I will bring you guys back to this project when I figure out how I'm actually going to hook the argon hose up. Might be as simple as just a hose barb and a push-on hose, or it might be as complicated as one of these little guys, the quick release push-in hose fittings. We'll see what I have and what I can make work. I'll figure that out and do another little mini episode when this guy is ready to be hooked up. Look, you can see the light coming through there. Look, light, no light, light, no light. Just to prove that it really is connected. That's it. Thanks for watching, guys. If there's anything you want to know, ask a question in the comments. Like and subscribe if you enjoyed it. And I'll see you next time.